All right, the next part of Chapter 9, I'm sure that all of the welders in the class are going to enjoy this, and you should pretty much know most of this next lecture part. But what we are talking about right now is going to be the way to join steel parts together. There are three ways that we can use, either through a metallurgical bond, or through glue, or some type of a mechanical fastener. So when we're talking about metallurgical bonds, that's joining the metals at the atomic level. Those ways include welding, brazing, and soldering. So your work pieces, or the two pieces of material to be joined, are called parent metals. And then the metal added to the joint is called a filler metal. And again, welders, you should already be familiar with that. So three requirements for a metallurgical bond. So the heat to melt either the parent or filler metal. So we've got to be able to get that to the right temperature. A disruption of surface oxides for all the metals at the joint region. And then, of course, protection from oxidation or contamination while the parts are hot there as well. American Welding Society has standards and offers standards and certifications for welding. Their definition is a process that melts part of parent metals so liquid forms a metallurgical bond between pieces with or without filler. And of course, they offer several different types of certifications and tests to make sure that you are qualified as a AWS welder. Brazing and soldering do not melt the parent metal. So they do form a metallurgical bond, but it's between parent metals with filler metal. So brazing occurs above 850 degrees Fahrenheit. Soldering occurs below 840 degrees Fahrenheit. So just some of the differences there between brazing and soldering. But in all these joining processes, the parent metal is heated in some way. So, and changes to the parent metal microstructure are very, very common. When we talk about these bonds, so we have surface oxides on the metal, especially if the metal has been sitting in a warehouse for a while. It may have developed different surface oxides, and those are going to hinder that metallurgical bond. So usually we want to do something to prep that material ahead of time to try to get rid of any type of surface oxide that might be occurred. So that will help those metal atoms to merge together as we do these particular processes. So your braze or solder fluxes help melted filler metal penetrate these oxides so that that metallurgical bond can be formed. We also need to talk about compatibility of the different types of materials that we're joining. So if they're not compatible, it's going to be very, very difficult. So if a joint has a very structural purpose, you cannot do anything that's going to cause it to become brittle. So remember that from a structural perspective, if that material is brittle, it's going to pretty much just snap and fail right away. So it doesn't give people any time to respond or react. So that's one of the dangers in making sure that structural materials are not real brittle or super hard because we want to have some time allowed as a structure starts to kind of fail that we can have a response time towards it. Nickel is a safely welded, is often welded to the steel rod. So as a way to help make sure that there's compatibility. So and these liquid metals will mix and form sound metallurgical bonds. So obviously some metals cannot be joined together. Aluminum is not metallurgically compatible with steel. So and aluminum steel welds form brittle compounds. So it's not real easy. Cast iron as well has its challenges there to be welded too. So when we're talking about welding, the parent metals are melted in an area that's to be joined. So we use a flux or some type of cover gas to protect that hot metal from the oxidation that can occur. So those flux and cover gases will protect the metal from the atmospheric moisture as well. So especially on very humid days, so we do get moisture in the air. So there are over 70 welding variations that exist that kind of produce different combinations of heat, filler, or shielding. So as you are learning, if you are a welder, of course, that's one of the things that you are learning in the welding lab as far as the differences between our different types of rods and different types of filler materials there as you learn how to weld as well. So we're going to go through some of these welding processes. We have small or shielded metal arc welding. So this is, of course, the most common method of joining metal, what was referred to as stick welding. So you do have a flux that melts and shields around the weld area. You have an electrode that is the filler metal there that's going in to fill up the two pieces of base metal. GMAW, so gas metal arc welding. Here is another form. So gas is either argon or helium. So when we're using that, the gas mixtures are chemically reduced. So, and of course, without flux here, there's no slag to chip off. So this is a process that kind of gives us a little bit more or less slag to chip off, and there are different reasons why we would use GMAW as opposed to stick. Just to bear in mind, obviously, you want to make sure when you are welding, safety-wise, to wear the right PPE as you go through. You don't want to wear anything that could be flammable or catch fire. Welding arcs do produce UV light, so you want to protect your hands and eyes from that. And of course, if you're working in that type of environment, you also want to make sure that there are curtains around or shields, larger type curtains, to also help protect anyone else that would be possibly walking around and exposed to that UV radiation as well. The next type here is gas tungsten arc welding, GTAW, gas tungsten arc welding. This uses a cover gas as well, so it's using non-consumable tungsten electrodes. So you do have a separate filler metal that can be used here as well. Probably what, TIG here is probably one of the harder ones to understand and takes a little bit more time and practice to develop the skills needed to use this type of welding process. In all of these welding processes, we're going to create what is referred to as a heat affected zone, or the HAZ. So again, as we're basically changing things on the molecular level, we are changing the microstructure of both the parent metal as well as the filler metal as well. And in general, the weld itself should be stronger as it's merging these two parent metals with the filler metal. So your weld should be stronger in most cases than the actual parent material itself. So usually if we do a destructive test on a weld, that's pretty common when you're learning how to do this, the weld should fail and it should break outside. So it should break in the parent metal as opposed to breaking in the actual weld area itself. So some of the problems in welding steel, of course, high carbon steels and cast iron can become very, very brittle. So they do require some special procedures to be doing this. You also have to have some preheating and post-heating practices to put into effect there as well. Those welds can develop cracks during cooling, so there should be inspected before it gets shipped out to a customer. Some of the non-destructive tests that are often used are what's referred to as a dye penetrant test. We might x-ray the parts to see if there are any internal cracks inside that weld. And then, of course, ultrasonic inspection is also occurring and can be done as 3 of the non-destructive tests that often gets done on welded steel. Welding small tubes. So Often we can use what's referred to as resistance welding to make small tube on tube mills. So we have a thin sheet that's roll formed into the tube, and then you have a friction stir welder or a resistance welding that kind of joins the two between there. So likewise, those tubes can then be drawn and annealed to get even finer or smaller diameter tubes as well. Resistance welding. So spot welding is a good example here in the sim lab. We have a couple of spot welders that are used, and of course, if you were in manufacturing processes class, you also have used those as well. They do contain copper electrodes that you press the two metal pieces together. Then you, of course, hit the electric arc on or the electric line on that to kind of create a connection between the two electrodes and fuse those materials there together. So spot welding is a type of resistance welding. So your electric current is what is used to melt the weld joint. So you do have to control the current and the time very carefully, and those electrodes have to be cleaned and dressed. So that's oftentimes, if you recall from our actual class, sometimes I have to go in and basically take the that copper out and do something to make sure that that electrode is still good. Friction welding is one of the more exciting, or one of the things that I think is a more exciting type of process, especially on larger parts. When you see some of the larger machines and equipment over in Danville, ThyssenKrupp has a very large friction welding machine for their crankshaft division. That's really, really impressive to see and watch. You get one part that spins and presses up against the other part. You're basically using that heat that's generated to form enough friction to melt the two together. So it's really quite a fascinating process to watch. So I encourage you to look up a couple of videos on friction welding just so you have an idea of what that particular process is all about. Forged bonding is a very old process. If we talk about the swords that used to be made here, and you guys have seen this on shows like Forged in Fire, where they basically will take and combine several pieces, heat it up, and basically then just hammer the two pieces together to get a nice strong type of material there in terms of forge bonding and welding those pieces together. Brazing, often done with copper, so it helps to get leaks, make everything leak tight quickly and consistently. So we use braze joints with filler alloys, so parent alloys are not melted again. And of course we use flux and controlled atmospheres here to make sure we get a good seal on that when we are brazing as well. Notice the capillary action comes into place again here with brazing, so we do want to get the filler alloy melting, and oftentimes in order to do that, the parent metal needs to be warm or hot as well, and we can kind of get that fluid, that filler, to flow and fill the spaces due to surface tension to create those brazed joints. So we do need to make sure that we are controlling the amount of heat that's going into it and the area of heating, as well as using the right flux and filler additions when we're brazing too. Soldering is a very common low heat type way to fuse these together. Again, we'll use in solder filler to wet the steel and fill joints in like brazing, but this is at a much, much lower temperature here. And of course, this is pretty common with electrical wiring, things where if we did have too high of temperature, we would possibly destroy the actual parent material. I'm going to stop right there with this, and then we will come back in the next video and finish this up.